to read it to yourself, and then we're going to read it aloud on the count of 3. Dr. Reagan, thank you.
Thank you.
It's nice seeing you, Dr. Reagan.
I was wondering, I want to see the boys a little more active in their responses to math. You know, we got to push them because they all sit back and let the girls take over the room. So get on them.
Okay.
Okay? All right, good, everybody.
Son, come on. Son, that's you.
A tissue, you sure can. You sure can. Does everyone have a paper? A blue sheet of paper? Tanaka, do you have a blue sheet of paper? I just asked the question, does everyone have a blue sheet of paper? Your hand should have gone up if you didn't have it. All right. Now that you've read, stay up. You're on the video. Now that you have, your blue paper, I need you to read. I need you to read the objective. On 3. Let's read. On 3. 1, 2, 3. Go.
Students will be able to describe the
Wait a minute. Here, babe. Here. The math.
Students will be able to create and identify angles by using right angles measurements.
Okay, let's stop. And let's read what we see.
We can't see the computer because of the computer.
Okay, well, let me help you. Okay? Let me help you. Students will be able to, say it.
Students will be able to
Create. Let me say it and then you repeat it because they cannot see. The computer and things are in the way, so I'm helping you. One more time. Students will be able to create and identify angles by using right angles. To determine whether the angle is equal to, greater than, or less than
Can we repeat now?
a right angle. Thank you. Have a seat. So again, let me.
You read it out aloud. You read it out aloud one more time.
Right.
Yes.
One more time. Well, they can't.
You.
Right.
Yeah.
One more time. I'll read it for you. Again, students will be able to create and I'm going to read it. Students will be able to create and identify angles by using right angles to determine whether the angle is equal to, greater than, or less than a right angle. So my question to you today is, what are we doing? What are we trying to accomplish today, Milan?
We are learning about how to identify angles left to right and how to switch them around.
Not angles left to right. Let's get some more help. We're going to build on that. Yes, Treasure.
We're going to identify angles. It says they're less than, greater than, or equal to.
How are we going to do that?
Oh, by using right angles.
Yes. So, in other words, sit up. In other words, what we're going to do is use a right angle as a benchmark, as a guide to determine what the other angles are. Okay? So we're going to use right angles as a benchmark to determine if other angles are less than the right angle or greater than the right angle or equal to. So on your desk, empty your mouth. On your desk, I gave you a blue piece of paper. This blue piece of paper is very important because it's going to become our template. I'm going to show you how it's going to become the template. So what you have now, you can pick up your paper. And while this is setting up, I'm going to model it for you. I would like for you to pick up your paper, and fold it. One time. Fold it in half if you will.
Otis.
Fold it in
Fold
half.
the
I just
picture.
showed you.
It's not straight.
Fold it in half. Good. Once you folded it in half, hold it up by the corner. By a corner. How many corners do we have now? 4. We have 4. So I don't care which corner you hold it by, but hold it by a corner. Okay, now with that being said, now we just created something. I would like for you to look at your right angle template, and where your finger is, which is on the corner. What's another name for a corner? What is another name for corner? You may not yell out. What is another name for corner? The same people. Simone, what's another name for corner?
Angle.
Sit right. Not angle. Starts with a V. Starts with a V. Yes, Tanaka. Vertex. Vertex. One corner is a vertex. One corner is a vertex. More than one is called what, Jamar? You need to stand up. It's called what, Jamar? Jamar? What is it? Okay. Vertex is one, and vertices is more than one, so 2 or more. Vertices, plural, vertex, singular, 1. You got that? Okay, repeat it. Vertex.
Vertex.
Vertices.
Vertices.
Excellent. Well said. What I would like for you to do is place your finger on the vertex of your blue folded paper. And now I would like for you to trace your vertex. Trace the angle, if you will, please. Trace the angle. I'm going to trace my angle. Here's my vertex right there in the corner, and I'm going to trace my angle now. I'm tracing my angle. There's my angle. You see my angle? You may trace it if that helps you. But I just wanted you to be able to see it up here. Trace. Put your vertex in. Good. Good. And so now we can see a right angle. Once we look at that right angle, take a look at it. What does it remind you of? Or does it remind you of anything? What does it remind you of? You make it a tissue. What does it remind you of? Look at your angle. Look at your angle and tell me. Look at the angle once you trace it. What does it remind you of, Mr. Blackwell? Stand up. I said once you traced your angle, what did it remind you of? What did you see? I'm going to draw one up here. Anyone help me out? Micaiah, stand up, love.
You know that thing that you're working on, like, this thing right here, that we be working on with the, line? Yes, isn't like this thing?
The diagram?
Yeah.
Is that what you were saying? Okay, but this is a picture of a right angle. But I'm asking you, when you look at this right angle, what do you see?
It looks like I see
You're yelling out. Micaiah, what do you see?
a L.
You see a letter L. It reminds you of a letter L. And that's what I wanted you to say. That was what I was hoping you would see. A letter L. Something else? Something else? Say it again.
It reminds me of a lamp.
It reminds you of a ray. Where is the central endpoint. Where is it? Mr. Faison, is your hand up to answer my question? On this ray, where is it? Come up and point to it. Come up and point to it. And then I would like for you to indicate by using a different color and make it big. She said it was a ray. Okay, then indicate that, please. Big. Good, very nice. Because what do we know about an angle again? And we have to remember this. We must remember it. Otis, what do we know about an angle, love?
Angle.
Yes. Tanaka, pay attention. Look at the angle. It's up there. What do we know about an angle?
An angle have straight lines.
Angles have straight lines. Okay, what else can we say? Something more specific, please.
Angle don't stop moving.
And what? Look at the picture and it's going to help you. An angle doesn't stop moving. It goes in what? One direction. What indicates the direction? What indicates the direction? What tells you the direction that it's going in?
Arrow point.
The arrowhead. Excellent, excellent. So, and I see you. I saw you. Excellent. Let's sit up. Sit up. So we have, sit up please. Sit up please. You're not going to do that. Sit up. How about you get up? Go out. If you don't want to be here, get out. I don't want you to get out. Thank you. So we get one and we use one. Okay, love. So here we are. Thank you, Faison, Mr. Faison. So we have our vertex, like we said. We have our arrowhead that's telling us this is the direction that we're going in. And we have two rays that make up an angle. Two rays. Now let's move on because we're ready. So with that being said, what can we say about a right angle? What can we say about a right angle? Think about it. What can we say about a right angle? I will tell you this much. A right angle is a 90-degree angle. You think? No, put the book up. We're not using the book. I didn't ask you to get a book, so we're not using it. We're using what we already know. We're putting it together. So look up here one more time.